I am.
Chris, me too.
My fingers are gonna fall.
Hi guys. Arya, I would like to know what's going on in school, Arya.
We just started like logarithmic.
What more?
We started logarithmic equations.
Okay. Changing exponents to logs.
Yeah, no, not change it. It's just like from logs. Like,
I see. I see. Directly they started with logs. So did you graph logarithmic functions?
I no, we did not. I don't think so. At least I don't remember.
Christian Dhwani is the same thing for you, right?
Yeah.
Yeah,
Okay, guys. Shrag be similar, right?
yeah. We had a test on Thursday on exponentials, so we didn't start anything yet.
Okay. Okay. Definitely go through the questions on the homework. So they are application related problems, right? If you have questions, always bring it back to class. Okay. You did the last was on half-life problems, growth, exponential growth problems. Okay. Okay. Did they talk to you about the difference between? I just want, out of curiosity, I wanted to know and let you know the difference between. If you're given a table, right, x and y values, do you know how to distinguish between linear, exponential, and quadratic functions? Guys, I really want your answers. If you're given a table of values, Pranav, do you know how to differentiate between logarithmic, exponential, and quadratic?
Uh, I know how to do quadratic and exponential, but not logs yet.
Not logs yet. Okay, just 1 second, guys. 1 second, you have to hold on, okay? Okay, guys, let's go ahead with differentiating them. Pranav, you said you don't know how to differentiate logarithmic functions, huh?
And now we're starting that this week.
No. If you're given table of values, do you know how to distinguish? Rituvara. How to distinguish between exponential, quadratic, and linear?
Yeah, I know those three.
Okay. Quadratic versus linear. Dhwani, do you know, ma?
Huh?
Do you know the difference between linear, exponential, and quadratic models?
Yeah, I mean, like if I look at a graph, yeah, I can tell.
Lemma, yeah, if you look at a graph, if you look at examples of tables, will you be able to differentiate them as linear?
Probably. If
Okay.
I like figure out some sort of equations for each one of them.
Okay, let me show you. This is what I'm asking. It's a basic thing. It's not a big thing to sit and solve for long, but then you should know how to differentiate. Let's see. What about another? 1 second, guys. Let me share my. I'll share the screen. Let me know whether you guys can differentiate whatever is shown. Okay, there are two tables given, right? Two tables on the board. So as soon as you see that, I should know if you can differentiate between Oh, this table represents a linear function. This table represents an exponential function. This table represents a quadratic function. So that sort of a difference I can go ahead and explain as well. But would you be able to say?
I could figure out which one's an exponential because you have to divide the second term by the first term.
Correct. But if there is a common, okay. So linear, let me
And
quickly.
like, don't like the amount of common differences tell you which one's like arithmetic geometry?
Yeah. If there is a common difference, it tells you that it's a linear function, right? It's arithmetic sequence, right? It's a linear model. Okay. If there is a common ratio, it tells you that there is a exponential model. Okay. The last one is how do you tell it's a quadratic model? If it is a quadratic model, the second difference will be the same. Okay. If it's a cubic model, the third difference is the same. This is just a concept you should be aware of. Okay. Now, when you look at this, right, see, there's a -4, -4, -4. See, there is a common difference between consecutive terms. Do you see it? For a change of 1 on the x-axis, you see there is a constant difference of, there's a decrease of 4, right? So this is a linear model. When you look at this, right, what happens? It gets multiplied by 2 is what I see, right? So there is a common ratio. What is the common ratio? 2 divided by 1. 2 is the common ratio. So this is an exponential model. Any questions there? Let's see one more quick. Okay, how about this? When you're given this table, right? So how do we do it? Here, there is no common difference between consecutive sequence terms. There is no common ratio between the terms as well. So let me see. See here, when you look at it, let's see. 21 minus 12, 21, the first term minus the second term, 21 minus 12 is a 9, 15 minus 12, 12 minus 5 is a 7, 5 minus 5 is 0, it's a 3. So now when you look at it, right, do you see? So this is called the first difference. This is the second difference. If second difference is always the same, then the table represents a quadratic model. Any questions here? Okay, so when you're given 3 models, right, you should be able to distinguish between exponential, linear, and quadratic models. Okay. Even to perform a regression, right, you should know which model better fits in. So you should be able to identify, hey, this is a quadratic model, this is an exponential model. Okay. Now let me go ahead and give you one sample. I hope you understood. For the quadratic model, I hope everybody understood. Let's see this one. I would like you to try 2. You can send the answers for both. Okay. Let me make it a little bigger. Sometimes it can be neither, meaning nothing, if nothing fits in, then it's nothing, it's none of these. Okay. So let's see. See this one. We'll do 2 problems in this and then we'll move on. How about number 1? Let me remove all of this. That's question number 1. Question number 2. After we solve this, we'll move on to the logarithmic functions. Number 1, number 2. see which model does it belong to, then we'll get on to logarithmic functions. Advani, you have the class calendar now? I would like to see.
Yeah, I can share it after I do the
And
problem.
Parvini, what are you doing in school?
We just had a test last week on the rational functions and equations.
Oh, okay. Have they covered logarithmic functions for you, Ma?
No.
I've not gone into base E as well. Hmm. Yeah, I just want to talk to you about E, base E. We'll do 15.1, but after this. Send both together, please, if possible. The first one is neither. Second one is exponential. Arya, is it so? Did you check?
Let me redo it.
Both, I feel. Uh, really? Cheryl, that doesn't seem right to me. Just last case. Dhwani, the first one is correct, second one is correct. Cheryl, the first one is correct, second one is incorrect. Parvini, the second one is correct, the first one is incorrect. Pranav, do you have your answer?
Yeah, one moment. I accidentally wrote something down.
Identifying see, it's a part of your book as well. Identifying linear, quadratic, and exponential models. If you graph it as well, you'll get to know. So that's Arya's first one is right, Arya. Second one is incorrect. Yeah, Ma, Cheryl, that's right.
Miss Priya, I sent you the calendar on
Yeah,
WhatsApp.
Ma. In WhatsApp, Amma. Okay, I'll check. Pranav, is that so, Pranav? The second one seems incorrect, Pranav. I will check. Ma, I don't have WhatsApp here. Hmm. Second one, Pranav, I want you to check on the second one. Sahil, guys, please don't keep quiet in the class. If you didn't follow, you have to rise up. And if you don't answer, you're not at all getting the productivity as well. I'll have to call you out, which I don't want to do. Sitara, I'm not getting answers, ma. See, if you
I'm working on it.
yeah, if you don't send answers, right, I feel like you're totally disconnected from class. Then there's no use attending the class as well.
All right, I'll send them.
Yeah. Similarly, Anirudh, I didn't get any answers from you. Is it that you didn't understand or don't want to do? Some answer has to be there.
I'm still doing it. I'm a big
Okay.
trying.
No, but if you don't understand, I would be more than happy to help as well. So, Arya, if it isn't a quadratic, would it be an absolute value table? Okay, what made you think? Even Cheryl also says it's an absolute value. Can you explain, Arya, why are you thinking that is absolute value?
Because I graphed it on my iPad and it made this position. Can you see it?
I see. The second one, huh?
Yeah, that's number 2. Because
Oh, why don't I try? Okay, hold
Yeah.
on. I do. See, only when you explain to me, I'll also know what you're thinking. -3 is a 1. Okay, -2 is a 0. -1 is a -1. Okay. And then 0 is a -2. 1 is a -1. Two is a 0. Oh, you're getting absolute value. That's why Cheryl, you should have explained to me, right? If you keep quiet, how will I ever know? Yeah, actually, fifth, yeah. Second one is correct. Correct. Second one is neither. Let me quickly check, guys, once. It's not linear as well. Okay, let me see. What did I give you? Okay. So basically, this one was a Krish, did you solve?
I thought I sent my answer.
Cheryl, I go with you, Cheryl. What you said was right. It's neither, ma. It's absolute value, so it's neither. It's not quadratic. It's not linear. So number 1 was quadratic. Number 1 was, I just asked you to choose between quadratic, linear, or exponential. So it is none of these, but it so shows an absolute value function model. So it's none of these, none of the ones that I told. Yep. Can I move on? Sahil, are you following Sahil?
Yeah.
Okay. Okay. I'm going to just move on to logs, guys. And I wanted to discuss base E. Like we have always dealt with functions like this, right? When x is an exponent, it's an exponential function. But have you heard about the number E?
Yeah, it, like has a value of 2.7 something.
Yep. So E basically is called the Euler's number. You just need to know what is E. As soon as you see the E, you should not be afraid. So E is basically the Euler number. The mathematician Euler came up with that number. Its value is 2.718 and it moves on. It's an irrational number. So basically it's 2.718. Instead of saying 2 power of x, you can say e power of x. It's again an exponential function, just an ordinary exponential function, but this e has a value to it, 2.718. Just remember. So it's another exponential function. Just because it is a letter, it doesn't mean, oh, it's a letter. No, I don't know how to do. Don't say that. It has its own value, 2.718. It keeps on going, but I'm just saying the first 3 decimals. Okay. Any questions? Okay. Now let's go here. How about this? We've always had 1 second, please. Here, let's see. We have 2 power of x, y is equal to y. So this is an exponential function, right? Y, x is as a power, 2 is the base, x is the exponent. Now, this function basically is something like this. Something like this, 2 power of 0 is a 1, so 0, 1 is a reference point for these functions. Now, function inverses, we have talked about function inverses earlier, right? How to find out the inverse of a function graphically. If you want to find the inverse of a function, what do we immediately do? We plot the line y equal to x, right? We plot the line y equal to x and treat that as a mirror, then we go ahead and do this. Right? We reflect it. So y equal to x will serve as a mirror. If we find out the reflection of our function on the line y equal to x, automatically we get the inverse function. Inverse function we get for the exponential. This, see, the red color thing was an exponential function. This represented 2 power of x, right? When we drew the line y equal to x and tried to find the inverse of the function, we got this inverse function. Okay, this inverse function is called a logarithmic function. So what I want to say is exponential functions and logarithmic functions are inverses. Okay, just like a cubic function, cube root, a square root and a square, they are inverses, right? Like that, exponential function and logarithmic functions are inverses. Suppose if I have a function a equal to b power of x. I have this function, right? This is graphically. Graphically, you know how to find out the inverse of the exponential function. Now we term that as a logarithmic function. Suppose if I say, hey, this is an exponential function. How to change it to a log? You know, this is called the base. This is called the exponent, right? This is the function. Okay. In this case, how to change it to a logarithmic function? All the while, when you're given cube function, you will take cube root on both sides to convert it to a inverse function. That's how we found out, right? So here, how are we going to change this exponential function to a logarithmic function? So basically, what I would do is, see, this is the base. Base always remains the same. Whether it is an exponential function or a logarithmic function, base remains the same. So I will write log of, I will write this one. Log of the exponential function, y value is there, right? That I will write, but the base will be the same. That will be equal to the base log of a. This one will be equal to x. Any questions here? Any questions here? Meaning, how did I change it? I made sure my base remained the same. The logarithmic base, logarithmic functions have a base too. This is called the base. The base remains the same. Logarithmic logarithm of this a, which was the y value in the exponential function, will be equal to the exponent. Make sense? So this represents your log function, which is the inverse function for exponential function. Any questions here? So I'll do an example now. One thing remember, I forgot to tell you here, b is always greater than 0 and b is not equal to 1. Make sense? That is a restriction you should remember for logarithmic functions. We had restrictions even when you converted the quadratic function, right? This was not a function, so you had a domain restriction, right? Like that. If you convert it to a logarithmic function, the base should be greater than 0 and base can't be equal to 1. Now let's see this one. Suppose if I have 4 power of 3 equal to 64. How do you change it to a logarithmic function? You see, this is the base. Base always remains the same. I'll put log and then this one, 64. Log 64 base 4. That is how I read it. Log 64 base 4 will be equal to 3. Any questions? If I want to convert this to an exponential function, I would start with the base. Base power exponent will be equal to 64. Make sense? See, suppose if you have cubic function, what do? You take cube root on both sides, right? When you, that's a reverse operation. So you get 4 will be equal to, if you take cube root on both sides, 4 will be equal to 4, correct? So like that, given an exponential function, how to change it to logarithmic function? The base will remain the same. You'll say log of the answer will be equal to the exponent. Similarly, if you want the other way, base power the exponent will be equal to 64. We'll do 1 or 2 more problems, you'll understand. How about this? 2 by 3 power p equal to q. Can you change, if I want to change it to a logarithmic function, I would appreciate if somebody can volunteer and shout out as well. Otherwise, I'll go ahead and say. Who wants to try? Who wants to try? Anybody wanting to try? Pranav, go ahead and try, Pranav.
Like,
The base remains the same. Make sense? Does that make sense?
yeah.
Okay, let's do a few more. How about, okay. 5 power of minus 2 is equal to 1 by 25. You know this is clearly an exponential function. How to change it to a logarithmic function? Hey, one of you, only when you try, you will clearly understand. Can one of you try this? Shall we try it together? I'll help you, right? Sahil, do you want to give it a try?
No.
Okay, no. Okay. Parvini, do you want to give it a try? I'll help you.
Sure. Is it log 1/25 base 5 equal
Log 1
to?
over 25, base becomes a 5. Base is always the base, and that will be equal to the exponent. Log 1 over 25, base will be 5, will be equal to minus 4. Makes sense? Now let's see this one again. This is hard initially. I know that it's hard. That's why I'm asking you to try. Let's see this one. How about 1 by 2 power n is equal to m. Somebody, Sitara, wants to try? Or Anirudh, do you want to try?
I can try, but I'm not sure if it's right.
I'll work with you.
Okay, so the base is 1/2, so it would be log 1/2 m equals n.
Yes, always you equate the exponent. Good job, man. Now, how about this? 1 by 3 power y equal to x. How do you write it as a logarithmic function? Anybody else try? Anirudh, do you want to try?
I can try it.
Go ahead, man.
Okay, so log based 1/3 x is equal to y.
Yeah, perfectly makes sense. So you all got a hang of it now. Okay, how about this? 2 by 5 power c equal to d. Somebody who is not sure, please help me. You do for yourself, right? You're not helping me either. Go ahead. If you're clear, you don't have to volunteer as well. If you're totally not clear, you should volunteer. Anirudh, do you want to give it a try? No?
No, I still need more.
You still need help. Okay. Sahil, how about you?
Log 2 5. 2
The
over
base
5.
remains the same, yes.
D equals to C.
Always the exponent is equated on the other side. Nice, nice, thank you. Now let's see this one. How about 1 by 3 power y equal to x? How do you convert it to log? The base is always the same, exponential function or logarithmic function, the base. This is our base. That remains as the base lower end. Okay, log, but what here? I have to equate the exponent here. So this x will come here. Make sense? Now, the other way conversion comes into picture. Anirudh, are you comfortable doing? Not yet? I respect.
No, just one more, just one more.
Okay, no problem. So let's try one more. Or one or two more I'll do. How about this? Yeah, okay, how about this? Log base 7x will be equal to y. Oh, no. This is reverse, right? I don't want to do this. Wait. I don't want to do this yet. How about 7 power of x equal to 343? Convert it to a logarithmic function. I'll convert myself. Okay. So basically the base is the same. Base is what is this, right? But then exponent is always equated. It should be on the other side. Now log base 7 of 343 equal to, log 343 base 7 equal to x. That's how I read it. Log 343 base 7 equal to x. Now let's try this one. I'll do one more. How about this? 1 by 3 power x equal to a 9 root 3. What I'll do? I'll say log, my base is the same, 1 by 3. But this 9 root 3 moves in here equal to the exponent. Shagvi, are you comfortable?
Yeah.
Okay, how about this, ma? Go ahead. One by 2 power x equal to 16.
Oh, log, wait, 1/2.
Yep, base remains the same. A log, actually, you have to say only this first, and then you can say the base. Log
And then times x.
is equal to x. The exponent comes.
Oh, yeah.
No problem. So here, 16.
Yeah.
Log 16 base half equal to 2. That's how it's read. We don't read the base first. Log 16 base half equal to x. Now let's do the reverse conversion and see. Okay. How about this? Log 7 root 7 equal to x. How to convert it to an exponent? This is very easy. You know how I do a butterfly like this. 7 power of x equal to root 7. Make sense? How do you find it? 7 power of x equal to 7 power of half x equal to. Converting from log is very easy. Just do a butterfly and then write the answer. Now, how about this? Log 1 by 3, 9 root 3 equal to x. This is pretty simple. Start from the base. Power x equal to 9 root. Make sense? Okay, I'll give you more problems with this. Only if we know this, we can move on. Okay. So I'm fine doing more problems in this. 2 by 5 d. Log d base 2 by 5 equal to c. How to convert it to an exponential function?
Miss Priya, can I try?
Yeah, please. I would love for you to try. Go ahead.
Um,
That's why you learn it here, okay? Don't make the learning happen elsewhere. Okay, the base you learn it here, it's easy for you. You don't have to spend time much after that.
2 by 5 power c equal to d.
Easy, right?
Mm-hmm.
Yeah, comparatively, it's easy. Even I have felt so. How about this? How about this? Whoever wants to try 10,000 equal to 4. Anybody would like to try? Cheryl, you want to try, Cheryl?
Miss Priya, can I try?
Go ahead.
So 10 to the power of 4 is equal to 10,000.
This is easy, right, Arya?
Yeah.
Comparatively, this is easy. Changing to log is a little harder. How about, how about this? Log 5, log 1 by 25 base 5 is equal to minus 2. So, Anirudh, do you want to try now?
Yeah, I can try.
Try.
So 5 to the power of -2 equals 1/25.
This one will be making sense as well. You'll really understand this working. But the other way, it's a little tiny bit hard. Fine. How about this? We'll go here. Okay. So the conversion should be easy now. Let's do a few more conversions before we go into the next subtopic. Okay. How about you have to write the log function, right? How about this? 1 by 4 power 3 equal to 1 by 64. Somebody wants to try to convert to log. Sitara, would you like to?
Sorry,
Sitara?
I was on mute.
Mm.
I'm not sure how to do this.
Okay, no problem. Ma. Parvini, you want to try?
Sure. Log 1/64 base 1/4 is equal to 3.
Base is always the base. In the exponential function, which is the base?
No, Miss Priya, I said log 1/64 base
sorry,
1/4.
I read it wrongly. I'm sorry. Yeah. 1 by 4. Sorry, ma.
It's okay.
That's perfectly correct. Okay, now, so you know how to do this. Now, as I said, guys, the exponential function, let's say 2 power of x. See, this is the beauty. I like learning it this way. 2 power of x equal to y. Okay. Now, let me put down some x and y values. You know function inverses very well. So I can show you how it works. X and y. This is not a part of anything, but I wanted to show you this. Let's say we have -3, -2, -1, 0, 1, 2. Okay, I put a -3. So I'll just substitute and find the y values, guys. 1 by 8, 1 by 4, 1 by 2, 0 means 1, 1 means 2, 4. So I have these values. I'm going to plot this basically. -3 is 1 by 8. -2 is 1 by 4. -1 is half. This is half, okay? And then 0 means 1. Okay, that's a point on the graph. I just want you to see what is going on. I'm not going to ask anything. 1 is 2, 2 is 4. So basically my graph goes like this. This is an exponential function. If you remember right, Dhwani, are you with me, Dhwani?
Yeah.
Okay. So this is an exponential function. It's beautiful to study this way. Okay. Now, when you look at the function inverse, right, I want to draw the logarithmic function. Do you know how to draw the table for the function inverse? What happens in a function inverse?
X and Y values get switched.
Exactly, x and y will switch, right? So I'm going to write 1 by 8, 1 by 4, 1 by 2, 1, 2, 4. I'm just copying from here. I'm not doing anything. -3, -2, -1, 0, 1, 2. Now let me go ahead and draw this. 1 by 8 is a -3. 1 by 8 is a -3. Okay, and then 1 by 4 is a -2. And then half is a -1. Half is a -1. Okay. Now let me position it a little bit. I have positioned it badly. 1 is a 0. 1 is a 0. Then 2 is a 1. 2 is a 1. 1 is in here. Okay. And then 4 is a 2. See what is happening? Do you see, guys? So basically, this is just a reflection of the exponential function. This is called the log function. See, when I switch my x and y, automatically I'm able to find the logarithmic function. But how do you write the equation of this? Just change it here. Remember, log base 2y will be equal to x. That becomes your this function. Did you guys get it? Now, when you think about the domain and range, right? That's always a property, right? Domain minus infinity to infinity. Range is 0 is not included to infinity here, right? In any exponential growth function. In logarithmic function, what happens? Domain range should switch basically, right? So when you consider the domain, what happens? Domain starts from 0 to 0 is not included again, infinity, because it switches, right? See here, it switches domain x-axis. On the y-axis, it is minus infinity to infinity. Makes sense, guys? Any questions? Any questions on differentiating exponential and logarithmic? How we arrive at logarithmic function? Logarithmic function is nothing but an inverse of exponential function. Okay, if you are able to draw the table or write an equation, you should be able to convert it to a logarithmic function. Okay, don't worry about the complex name. It is just logarithmic function. Exponential function, logarithmic function are inverses. The domain of this will become the range for the other, range of this will become the domain of the other, y becomes x, x becomes y. Graphically, it's just the reflection of exponential function on the line y equal to x. Any questions? It's beautiful to understand how it all works, and then you won't have many questions. You can break your head and solve any difficult question given as well. How about this? Okay, so now that we know this, let's move on to this one. How about this? F of x equal to log x base 10. They're asking us to find f of 1000. How to find this? We can't work with logarithmic functions. Without a calculator, we cannot work with log because we don't know the values. We don't need to know. Can we convert it to exponential functions and see? I will write this as y equal to log x base 10. Can I convert it to exponential functions? See, what is this value in here? They want us to find f of 1000. So what is that value in this equation? 1000 is what value?
The like what like the
Compare both.
what it equals to.
X is equal to 1000, right, ma?
Yeah.
So I can just put, they're literally asking what is the value of log 1000 base 10. How am I to find? I'm going to convert it to exponential function. 10 power of y is 1000. What is y? 10 power of y is equal to 10 power of 3, y equal to 3. Any questions here? Any questions? When you think about it, right? That y. So now you know y equal to 3. So f of 1000 will be. Make sense? If I'm asked to find out what is f of root 10, how do I find it? They are asking us to substitute x equal to root 10. Let me write it down. Y equal to log base 10 of root 10. This one is 10 power of y equal to root 10. Please convert radicals to rational exponents. See, y equal to half, amma. Half, right, ma? Dhvani. Dhvani, did I make it clear?
Yeah.
Okay, good. Now let's try this one. How about I give you this? F of x equal to log x base 1 by 3. Okay. Now can you find out what is f of 27? It's just that they're asking you to substitute x equal to 27. If you substitute f of 27 means that becomes your y value. F of 27 is what you need to find. Just substitute x equal to 27. But you can't solve this because it's a logarithmic function. So put this f of 27 as y. Y is what you need to find out. So convert it to an exponential function, find the value. Dhvani, I'm checking your answer, ma. Give me a minute. Yes, ma, Dhvani, that's right. Arya, that's right, Arya. So f of 27 equal to, I'm going to rewrite this. For those of you who didn't get it yet, you can check it out. Log, see, I'm just copying this in here. Okay, I can't solve this because I don't know the log values and all. So I'll convert it to exponential function. How do I convert? The base remains the same, remember? The base, we'll start with the base and then the butterfly. 1 by 3. I can't write f of 27. Let me write it out as y. 1 by 3 power y is what I need to find out. Will be equal to what? 27. 27 can be written as 3 power of 3. 1 by 3 can be written as 3 power minus y equal to 3 power 3. Now the bases are the same. Minus y equal to 3 means y equal to minus 3. Krish, are you following Krish?
Yeah.
Now let's try this one. F of x equal to log x base 7. Okay. Can you find out f of 1 by 49? Question number 1. Question number 2, can you find out f of root 7? 2 questions, guys. With this, I'm going to move on to the next topic. Logarithmic function using a calculator is not hard. Yeah, but I just want to tell you the difference between log and ln. Let's see. I'll also give you an overview of the transformation of logarithmic functions. Should be easy. Okay, and word problems we'll solve more next week. If you're not getting, please send a message to me. Auntie, I didn't understand. Then I'll explain, right? Instead of wasting time. I'm checking your answer. 1 by 49 and root 7. Correct. Oh, wow. Nice to see answers, guys. If you didn't understand as well, you can let me know and do it on the board. Yeah, everybody who sent it got it right. Yep. Oh, nice. This is required. Okay, pre-calc again starts with only this exponential logarithmic function in detail again. So there's no way. Better learn it now. Okay, no problem. Okay, where are you getting stuck? Tell me. I'll help you. Go ahead, Anirudh. Where are you getting stuck? From first itself, you're not able to understand.
No, I got the first one. I just need help with the second one.
Sure. See, this can be written as 7 power of half, right, Anirudh? Okay, no problem. For the
Yeah.
first one, what did you do? Did you substitute f is equal to 1 by 49? Did you substitute that?
Yeah, I did. Sorry, I was on mute.
I'll write it out as y. Y is what I need to find out, right?
And that'd be it'd be negative
What
2.
1 by 49? 1 minute. Let me put it out. 7 power of y will be equal to 49 is 7 square, but it can be written as 7 power of minus 2. So y equal to minus 2. You got this? Okay. The second one, when you look at it, I'm going to substitute f of root 7 will be equal to log root 7 base 7. Now, I don't want to maintain this like this. So y is what I need to find out. So again, like this, 7 power of y equal to root 7. Root 7 is 7 power of half converted to a rational exponent, fraction exponent. So y equal to half. Make sense? Shagvi, did you get it?
Yeah, I sent you my answer.
You got it? Okay. So, yeah. So now let's see this one. Okay. Now, can I move on or do you want to do more problems in this? I don't get this. Okay. Sahil, how about you?
Yeah, I understand it.
Okay, then let's move on, guys. Okay. Then in the homework, you can do some problems as well. How about, okay. One thing what I want you to know is, I can say log, okay, to any base. But if I don't give you a base at all, if I don't give you a base and just say, hey, what is log 100? If I say this, it implicitly, like if I give you a radical and give you, you read it as square root. If I don't give you anything, it is implicitly, it means it's a square root, right? So like that, log, if I give you just like that without any base, it is log base 10. Okay. Sometimes there's something called the E function, Euler number is there, right? That can also be a log base. Okay. When you look at log E, let's say if I ask you this This is sometimes written as ln 100. If you see the word ln, then it refers to natural log. These are definitions guys. Okay, this is log base 10. If you're given just like that, log 2, then it means base 10. If you see the word log without any base, it's base 10. Whereas if it is log base e, they can refer it to as ln. We will come back to this again. I just wanted you to know the know some definitions. Okay, we'll come back to this again. 100% we'll discuss more in detail. Suppose if I give you ln 200, it just means that I am saying log base e, log 200 base e. Let's leave it in here. We'll come back to that. See, why am I telling you that? Because without the base, you cannot convert it to an exponential function. You won't know what is the base. That's why I'm telling you. They give you this ln, then it means that it's base e. But we'll come back to that in detail. You don't have to break your head on that. There are a couple homework problems in that. So I discussed that. Let's see. How about this? Okay. Now, the population P of a bacteria, is given by this equation. Okay. How long will it take for the population to reach this? How long will it take for the population to reach this value? So this is your final value of the population at time t, right? So you have to find out t. Guys, all the while we did such a problem in exponential functions as well. But what did we do? We plotted this as a separate function, this as a separate function to find out the value of t. That was hard. We found the intersection. Now that you know the conversion, right? See here, 1,792,000 will be equal to 3,500, 2 power of t by 73. Now, divide by 3,500 on both sides. It's very easy to convert log to exponential to log. So if I do this, 17920 by 35 will be equal to 2 power of t by 73. But how do you find this? Can one of you tell me what is 17920 by 35? What is that? Yeah, I need answers. What is it, ma?
51.2.
51.2 will be equal to 2t power 3. Now, this is an exponential function. Unless I bring that exponent down, I cannot find values, right? So, how to change it to a logarithmic function? The base remains the same, right? Log base 2. But what do? I equate the exponent here. I put this value in here. Now, do you see log 51.2 base 2 will be equal to t by 73. So, the t can be equal to multiply by 73 on both sides of the equation. Log base 2 51.2. For this one, I can go to the calculator. 73 times log 51.2. Let me see. Let me try to bring 384.
Miss Priya,
Yeah, ma?
isn't it just 512?
Oh, did I make a mistake? Oh, is it 512?
Yeah,
Somebody said 61.2, right?
because like
17920 by 35 is what? Yeah, looks like it should be a 3-digit number, right, ma? Yeah, it is 5 and 2. Correct. That's okay. Okay, it is 5 and 2. Okay, now let me. Can you shout out that equation? Can you shout out the equation? I want to do it in the calculator and show you. Let's see. What was that, ma? Log?
along to
No. I want the equation, ma. Okay, let's solve. bacterial population I gave you, right? Bacterial population will be 3,500 T 2 power of
2T.
2 by 73, right? This is what I gave you. After that, we had some number for this one. When will it reach the population of 1792,000? 1792,000 is what I asked you. So this will be 2 power of T by 73. Now divide by 3,500 on both sides. I cannot bring that screen in here. That's my problem. Now this will be 512 will be equal to 2 power of T by 73. It is an exponential function. You would want to convert it to a logarithmic function. The base remains the same. So what would happen? Log 512 base 2 will be equal to T by 73. Multiply by 73 on both sides. 73 times log 512 base 2 will be equal to T. That's all. So you already found it. Now it is going to, you're going to make your calculator work literally. Let's see how to do. I forgot. I'm going to see. So here, do you see log is there? We are going to do log base 2, right? Oh, we don't know how to calculate the log base, right? Hold on. Okay. Is there a way to do the log base? Give me a minute, guys. I need to check. Because I can convert it to log base 10. I don't know. TA84 log base 2. How do you do that? Yeah, see, press the math button, then you have the log base. So I want to calculate 73 times log base, log 512 base 2. So I go to where is the math button? Where's the math button, guys? Can you help me?
It's right below the green alpha.
Sorry, yes. Math la is a log base. Ah, yeah. Do you see the log base? Yes. Log base 2. Then I go up and type the 512. I get the answer, right? 9, right? Now, if that is equal to 9, 73 times 9, right? 73 times answer. There'll be one answer button, right? 73 times. Seventy-three times answer is here. Enter. Something feels wrong to me. Yeah, 6:57. That's right. So the time is 57 minutes. Makes sense, guys? This is how you solve word problems by converting exponential functions to logarithmic functions. What did I say? 6:57. The time is in minutes. Any questions here? So the important aspect is they give you the equation, okay? You just need to plug in numbers. But the thing is you're stuck here. After this, you don't know what to do. Convert it to a logarithmic function, type it into your calculator, get the answer. Make sense? Make sense? For next week, I would go ahead with transformation of log functions and log equations. Transformations and log equations we'll solve next week. For this week, we just found out how to convert exponential to log, log to exponential, and then what did we do? We did some word problems as well. Can I give you one problem? See whether we can do, and then let you go. I'll do that. How about this? You're going to calculate this one. Let's see. I'll do it in the same page so that we can use the calculator. How about this? This is an easy one. Again, the population of bacteria problem itself is solved. Okay, it's given by 1000. See, here it is e power. Here it is e power. Okay, let's do this one. 1000 e power. When okay, I want to do this and show you as well. E power 0.0277 t. Okay, now the question is asking how much time will it take for the population to reach 1 million? How much will it take for the population to reach 1 million. It's not tricky, okay? If you think about it, it's not tricky, but you need to use E. If you have ln E, see, log base E can be referred to as ln in the calculator. This is the button. Ln E, but ln is here. Do you see? Log base E is ln. So what I would do, I would divide by 1000, divide by 1000. So 1000 will be equal to e power of 0.0277t. Now I have to convert it to log, which is the biggest part. So I will write log 1000 base e will be equal to 0.0277t. Now divide by 0.0277, divide by 0.0277. Log base e, I can change and say ln 1000. Ln 1000 natural log, that's sometimes called natural log, will be equal to t. Now, if I want to type that into the calculator, I will do ln 1000 divide by 0.0277. That gives me, correct, 249. So approximately 249 minutes. Any questions, guys?
No.
Okay. So only thing what you need to know is this base E is very, very weird. Okay. The Euler number. So when you have a logarithm to the base E, you can use the ln in the calculator. Log base 10 is the base 10 logarithm. If they don't give a base, then you take it as 10. Okay. Log refers to log base 10. Log base E refers to ln. At least in the calculator, you should know how to use it. Okay, I'll stop here, but
Miss
let me
Priya,
know if you have questions. Yes, ma'am.
we always round it.
Yes. Particularly logarithmic questions, you will end up rounding.
Okay, thank you.
Okay. Any questions? If you have any questions, okay. Otherwise, all the best. I think you have EOCs going, right? Ongoing EOCs. All the best for whatever EOC, whoever is attending. We'll see you all next week.
Bye, Miss Priya.
Bye, guys.
Bye, Miss Priya.
Thank you,
Thank
Miss
you.
Priya. Bye.
Bye, guys. Hey guys, how are you all?